Hello everyone, I am Teacher Anton. I'm here to teach you on how to solve math. This is the part 2 of the video from the lesson Polynomial Equations and the Rational Root Theorem. This lesson focuses on solving higher degree polynomial equations. Finding the roots of this equation can be quite a task. The rational root theorem only gives the rational roots of polynomial. It does not give all the actual roots of the polynomial. Some roots may be irrational or imaginary. When we say imaginary or imaginary number, we were once thought to be impossible, and so they were called imaginary. We have no word real numbers if there is no imaginary numbers. Imaginary numbers like this, the variable I is equals to square root of -1, and I squared or raised to 2 is equals to -1. If I raised to 3 is equals to negative square root of -1. I raised to 4 is equal +1. And I raised to 5 is equal to square root of -1. And I raised to 6 is equal -1. Or so on. Now the questions I prepared is determine the roots of equation number 1, j raised to 4 plus j raised to 3 plus j raised to 2 and minus 9j equals 10. First you will do is to equating to equal to 0. J raised to 4 plus j raised to 3 plus j raised to 2 minus 9j minus 10 equals to 0. All the given is not equal to 0, you need to equate to 0. Then transpose the positive 10, it changed the sign to -10. After equating to equal to 0 and determine the roots, you will use synthetic division. Then set up a table for synthetic division. We have no divisor. All you have to do is to find the value of x. Since the given is there is no value of x, you need to guess what is the value of x. To determine the remainder is 0. If the value of x and the process of synthetic division and the remainder is not equal to 0, you need to try another or to find the value of x until the process or the remainder is equals to 0. Now let's try +1. What if the value of x is +1? Then, this is the new equation. Coefficient of j raised to 4 is +1. J raised to 3 is +1. J raised to 2, +1. And -9. And last is -10. Then bring down 1. 1 times 1, 1. 1 plus 1, 2. 2 times 1, 2. 1 plus 2 is 3. 3 times 1, 3. -9 plus 3 is equal to -6. -6 times 1, -6. Then -10 plus -6, -16. The remainder is not 0, is not equals to 0. Since this is not equal to 0, the value of x or 1 is not a root. Since positive 1 is not a root, Continue finding another rational root. What if x is equals to -1? Let's try. Since the positive 1 is not root, then set up another synthetic division. -1. Coefficient is 1, positive 1, positive 1, -9, -10. Then process, bring down 1, 1 times -1, -1, positive 1 plus -1, 0, 0 times -1, 0, 1 plus 0 is 1, 1 times -1 equals -1, and -9 plus -1, -10. -10 times -1, positive 10. The -10 plus 10, 0. Since the remainder is 0, -1 is a rational root. This is the divisor, and this is the quotient, and this is the dividend. Since there are only 4 remaining coefficients of the quotient, it means the quotient is already a cubic equation. Continue finding another rational roots until the quotient it becomes quadratic equation. Set up another table for synthetic division. Then try to find the value of x. You need to guess or try an error until the remainder is become 0. What number of the value of x? Let's try positive 2. X is equals to positive 2. Then continue. This is the quotient. Then bring down 1, 0, 1, -10. Don't bring down the remainder because remainder is not the dividend. Because the remainder is not the quotient. Since 0, no need to copy 0. Only the 4 coefficients that remaining. Now continue, bring down 1. 1 times 2, 2. 2 plus 0 plus 2, 2. 2 times 2, 4. 1 plus 4, 5. 5 times 2, 10. -10 plus positive 10, 0. The remainder is 0. The positive 2 is a rational roots. What have you observed from the remaining coefficient in the second synthetic division process? There is 3. It means the quotient is already quadratic equation. Since the quotient is already a quadratic equation, then form it into quadratic equation by x raised to 2, represent as the highest degree, and it is called as quadratic equation. Positive, which is positive 2, x, from highest, then lowest is imaginary 1 exponent, plus 5. Then equal to 0. Now we have our new equation called as quadratic. Then arrange it in the descending order from the highest degree. Plus 2x plus 5 equals to 0. Then observe the equation if the quadratic equation can be factored or not. So since x raised to 2 plus 2x plus 5 equals to 0 cannot be factored, what you will do? Then find another way to factor the equation. How? Try to transpose the last term or the real numbers. X raised to 2 plus 2x plus 1 is equals to negative 4. Then this equation can factor. What technique that you will use? Box method. Then try the box method. Here x and x. X times x squared. Since the equation is x raised to 2, what coefficient that you will write here, you need to add. The result is the second term, 2x. Since 2x, we have x and x, then plus 1x plus 1x is equals to 2x. Why is it 1? X times 1 equals 1x. 1, positive 1, positive 1. X times positive 1 equals positive 1. Then positive 1 times x, positive x. If you add 1x plus 1x equals to the second term, which is 2x. How about this last box? Positive 1 times positive 1 equals positive 1. The 1 is located from the last term, which is positive 1. Then use this pair. Put in the parentheses x plus 1, then x plus 1. Have you observed the factor? They are the same variable, same sign, and same coefficient. Then let's combine. Don't forget the negative 4. Combine into 1, x plus 1 raised to 2 equals negative 4. X plus 1 raised to 2 is equals to x plus 1 parentheses times x plus 1. Then apply the square root method. If you apply the square root method, both sides. The important is, if you apply square root from the right side, then apply from the left side. To be fair. Now continue. Square root cancel, then power of 2 cancel. The remaining is x plus 1 equals square root of negative 4. In scientific calculator is mathematical error. So use the imaginary that 4 is 2. 2. How about the negative? Negative I plus minus. If there is an imaginary, you need to write plus minus. All the coefficient has an imaginary I, you need to write plus minus. It means there is a positive and there is a negative result. We're not done. Continue. X plus 1 equals plus minus 2i. Then transpose the positive 1. Since we need to find the roots. Then x is equals to negative 1 plus minus 2i. This is the final answer. Then since plus minus, we have the result of positive and negative 2i. So therefore, we have the roots are negative 1, positive 2, negative 1 plus 2i, and plus negative 1 minus 2i. Why is it negative 1? From the given of the synthetic division, which is negative 1 is a rational root. Why there is no positive 1? Since the positive 1 is not a root. So this is not a rational root, so no need to include because this is not a root. all rational roots are -1 from the first synthetic division process, +2, which is the second, and the third is -1 plus 2i from the result, and lastly -1 minus 2i. There is positive and negative since the result is plus minus. So that's it. Now let's proceed to the second problem. The second problem is find the polynomial with integer coefficients that satisfy the given conditions. The questions here is p sub x has the degree of 3 and roots I, which is the imaginary, and 2. As I said, if there is an imaginary, we have a plus minus. We have the result of positive I and negative I. Now let's p sub x equals x plus I times x minus I plus times x plus after 2. This one, then continue multiply the first to the second term by using the FOIL method from the first, outer, inner, and last. First, which is x times x equals x squared, then x outer, x times negative I, negative ix, the inner, positive I times x plus ix, then the last, positive I times negative I squared. Then bring down x squared, negative ix plus ix comes 0, cancel. Then the remaining is x raised to 2 and negative I raised to 2. What is the value of I squared? I squared is equals to -1. Since I squared is -1, is equals -1, then we have minus, then -1, then multiply x raised to 2, negative times -1, +1. Then bring down the last multiple, which is x plus 2, x plus 2. Then apply the FOIL method from the first, outer, inner, and last. First, x squared times x, x cubed. The outer, x squared times 2 plus 2x squared. Inner, 1 times x plus x. No coefficient 1 because it's already have an imaginary 1. All variable has an imaginary 1. Then 1 times the last, 1 times 2 plus 2. The final answer is p sub x equals x raised to 3 plus 2x raised to 2 plus x plus 2. Since the answer is arranged in a descending order, so no need to arrange, then the equation is cubic equation since the highest degree is raised to 3. And from the questions here is p sub x has the degree of 3. So correct. which is the highest is 3. Thank you and God bless to us.